All right, let's do this. For the second one, guys, make sure to participate because I'm going to be asking you to provide the answers. Oh, this is the TI Inspire. Let me just 1 second. Let me get the other calculator, please. The first thing that you have to do is to enter the data that you have in L1 and L2. So we go to Stat, Edit. And now L1. So you got 1, 0, 3, 1.5, 1.5, sorry, 2.75. This is the independent variable. Then 1, then 0.5, then 2. Next one, 78. So the students who studied for 1 hour got 78 on the test. The students who didn't study got 75. The one who did 3 hours got 90. 1.5 hours got 89, 97, 85, 81, 80. They have to be a match, guys. Same number of values in L1 must match with the number of values in L2. If you have one more or one less, that means you made a mistake. Okay. He wants a linear regression equation. He wants a correlation coefficient. Okay. Do we still remember, guys, what to do with a student? Please remind me what are the steps in order to get the equation and the sample correlation coefficient. What do we do? Yes?
Go to Stat and Calc. And,
Thank you.
Number 4.
You got it. See, it's not difficult. So make sure you have L1 listed there. L2 is listed, and don't do nothing else, guys. Just go to calculate. By default, the calculator will use L1 and L2. So if you use L1 and L2, you're in good shape here. Okay. So let's say I ask you to do the equation of a regression line with 3 decimal places. So we're going to write the equation. Okay, it is y hat. Remember, guys, we said we call it y hat because it comes from a sample equals ax plus b. So 5.425 x plus b, 76.406. Okay, that was the equation. Correlation coefficient R, guys, it's 0.786. Let's say 3 decimal places. Okay. Type of correlation, I think it is positive because R is a positive. So it is positive linear.
Can you explain one more time why it's positive linear?
Because the value of R, depending on the value of R. If R turns out to be positive, the correlation is positive. That means as X increases, Y increases. Negative correlation means as X increases, Y decreases.
Thank you.
Now, is the correlation strong? Probably not very strong, because I told you when R is very close to 1 or very close to -1, we say it is a strong correlation. So I wouldn't say, just that this correlation is strong. It's 0.78. So probably not. because R is not very close to 1. Okay, guys.
Considered strong. Anything between the 8 and 9 range?
Yeah, if it is like in the high 80s, 90%, yeah, I would say very strong.
Okay.
But less than 80, there is correlation, but it's not very strong. And you're gonna see the graph, guys. Once you see the graph, you'll be able to tell. Use the linear regression equation to predict a student test score if he studied for. Let me change this one here. If he studied for 2.5 hours, change it to 2.5 hours. And the reason why I changed this one, because 4 is outside of the range, guys. It has to be within the range. So I'm just going to make it 2.5. So if he gives you the X value, guys, you just plug it in. So Y hat will be 5.425 times 2.5 plus 76.406. Okay, let's put that on the calculator and figure this out. All right, so if I do 5.425 times 2.5 plus 76.406, I got 89.96, almost 90. A score of 90. Okay, now the scatter plot. He wants us to do the scatter plot right here. And let me show you how we did that last time, guys. You don't need to do anything by hand. Watch. First of all, make sure that stat plot is turned on. So you press the second key and Y equals. Press enter. And look, it is on. The type, the first one is selected. That's the scatter plot. That's all you have to make sure. And then if this is good, you just press on zoom and then number 9.
We press second and then what?
A second and Y.
Second and Y.
Second, let me show you again, and Y. And then press enter. You should see this screen. Do you see this screen right here? And then make sure that on is selected right here. And then type is selected right here. For example, let's say you have this from before, guys. That doesn't work. You have to scroll here. Look. And press enter. Anytime you select something, you just press enter. Just like in Word, you have to press enter, to move to the next action. And same thing here. And then once you're done with this, press zoom and then number 9. And you can see the scatter plot. Now, if you are, guys, if I give you a grid and I ask you to show me the scatter plot and you want to approximate this, this is what I would like you to do. Just try to mimic what you see here. So something here, there, something here. I'm just trying to copy it. And here you go. Then you get full marks, just by doing something like that. Okay.
So that would be like considered correct on the exam?
Yeah, 100%.
Okay.
I'm not going to have you just go and plot each point. I mean, we could, for one, look, for one, you have to go to 78, which is right here. And look, we're close. We're very close. For 0, it's 75. I should have been a little bit higher here, 75. I mean, we could do that easily, but an approximation is good too. Like for 3 is 90. Watch, this is 3. It should have been 90. It should be right here, somewhere here. I put it. So this one I could have moved and put there, but that's fine. All right. So if you are to draw the line of best fit, guys, do you guys have an idea where would the line be? If I asked you to just draw this equation of the line right here, If you draw it, guys, it's not gonna be this, and it's not gonna be here. It's gonna be somewhere in the middle, guys. It will be like this. That's the line of best fit. That's what we call, they call it the equation of the regression line. You see, it says linear regression equation, or it's called the equation of the line of best fit, or it's called the equation of the least squares line. If I ask you any of the three, it's exactly the same thing. You have to find y equals ax plus b. You want to see on the calculator how this looks like? I'm going to graph it on the calculator. Look, how do you graph lines on the calculator, guys? You go to y equals right here, and then you enter the equation of the line. I'm going to enter it 5.425x. Look where x is, guys. If you're wondering about x, it's right here. Plus 70.406. Okay, and now hit the graph, guys, right here. That's the equation of the line of best fit.
Does the line typically always go through the middle like that?
Yeah. If you have a balance of points above, points below, it has to go through the middle in here. But my points should have been a little bit lower if had I looked at the grid here a little bit more carefully, so it would change the line a little bit. But the calculator one is the correct one. It's 100% correct. Okay, let's go and do the second one. Just practice. So mainly, guys, this is what you need to know, how to find R. That's very, very important. I can tell you 100% you're going to see questions like that. Comment on the linear relationship. We're going to do a couple more similar to this. Given an X value, find the Y value. You're going to do that. Find the equation of the regression line. You're going to do that. And then perform the test, which will come in another question. Now, yes.
Sorry, so you explained how we find if it's positive or negative, but what about linear? How do you determine if it's linear or not?
Oh, it's linear. If R is above 0.5, it has to be linear. If R is very close to 0, we say it's not linear. Since 0.78 is not close to 0, so it can't be non-linear. So if R is close to 0, which unlikely to give you a problem like this, like let's say R turned out to be 0.1, you can be sure it's not going to be linear. It's going to be points scattered all over. You wouldn't even be able to determine. But look here at the scatter plot. You can have a feel that it follow a line. It does follow a line here.
Okay, thank you.
Okay, next one. No problem. Okay, guys, now I need your participation. I'm going to ask you what to do. You're going to privately chat with me and give me the value of R. I'm going to show you the work. All you need just to do exactly what I'm doing. The table below gives the amount of Krabby Patties made by SpongeBob for each year his work. I'm sure all of you know SpongeBob. I had to put this cartoon up for so many years because my daughter, just loved that at that time. Graph the data on a scatter plot, find the line of best fit, and write the equation of the line. So same thing as before. Let's do this. So I'm going to clear. Here's how you clear the lists, guys. Let's do that step by step. Go to stat. Oops, sorry. Let me quit. Here's how you quit. If you want to quit a screen, guys, you just go second and mode, and then you can quit. So I'm going to go stat, edit, and look. You go to L1, scroll up, hit clear, and enter. That clears L1. Go same thing, L2, hit clear and enter. And now they're cleared. And now guys, go ahead and enter your data. So year worked and Paris made. 1 year, 2, 3, 4, 6, 8. And then L2, 6,500, 7,805, 10,835, 11,230, 15,870, and one more, 16,387 Paris. All right. So here's what I want from you guys. I want you to find the correlation coefficient R and text it to me privately. And to do R, here's what you do. You press on stat. Let me bring this closer. You press on stat. You select calc. And then you select number 4. And you should be able to see R. If R doesn't show when you do number 4, that means your diagnostic is not on. If your diagnostic is not set to on, guys, here's how you set it up to on. You just press the second key and number 0 to access the catalog. And then you scroll down until you see diagnostic on and press enter. Let me show you. You must do that, otherwise it will not show the value of R. There you go. I don't know if there's a shortcut to get there quicker, but I don't know. There you go, sorry. Diagnostic on and press enter. And enter, that's it, until it says done. So again, you go to stat, calc, number 4, and check L1, L2, hit calculate and give me the value of R, guys. So R is 0.972, Y hat is, A is 1510. Let me do it one decimal place, 0.1x, just to allow room. I will tell you exactly how many decimals. 5397.5. Okay, type of correlation, guys. Positive linear. Of course, positive linear here. Correlation strong, actually very strong. And why? Because R is very close to 1. Either close to 1 or close to -1. Either way is good. But here it's a positive way because R is very close to 1. Use a linear regression equation to predict how many crappy Paris he will make after working. Let's make it 7 years. Okay, so I'm gonna change this one. So what are you gonna do, guys? Just take the 7 and plug it in. $1510.1 times 7 plus 5,397.5. So I got 15,968. So it will be 1510.1 times 7 plus 53. It's just pure algebra here. So we're not doing any statistics here. 15,968 Paris. Okay. If you want to see the scatter plot, guys, here is the scatter plot. Watch. You go to y equal. Sorry, zoom and number 9. You see, if you're asked to just jot it down, I would just do something like that. That's the scatter plot. And the line of best fit, guys, I think it's just going to be something like this. That's a line of best fit if you are to graph it. Okay, we're going to go to the third one, which is a re-review of chapter 9. This is the kind of the question, guys, you should expect to see on the test. That's going to cover chapter 9. So the table below shows the weights, carats, and prices of randomly selected diamonds. The values are based on the data from the retailer Blue Nile. So this is a real data that I got here, guys. I didn't make it up. Find the correlation coefficient R and interpret its meaning. But before we find the correlation coefficient, we have to put the data in L1 and L2. So let me just do that quickly. Find the correlation coefficient R and interpret its meaning. So here's what you do. Stat calc number 4. Okay, and so R is 0.98. So you say very strong, positive, linear correlation between weight and price. And you know that this is the true case because I gave you this example about the diamond on Monday, guys. You know, as the weight of the diamond increase, the price increase big time. Find the equation of the regression line round to 3 decimal places. You already have the equation on the screen, guys, and it's displayed as y equals ax plus b. You put y hat just to say that this is extracted from a sample, and you put 6960. I'm going to make it 1 decimal place only, guys. X plus b, which is negative 1936.2. That's the equation of the regression line. Any questions? Around to 3 decimal places, I'm sorry. I'm going to change it to 1. Is there a sufficient evidence that there is a strong positive linear correlation between the weight and the price of diamond? Okay, he says, test for positive correlation. You remember, guys, on Monday, I showed you the 3 scenarios. I'm going to put them on the side here. You have to choose always one of them. So we're going to test the population correlation coefficient rho. It's either equal to 0, not equal to 0. That's one scenario. That's the other scenario. And the third one, guys, you have always to choose one of the 3. No other choices. Rho is less than 0. R is the sample correlation coefficient. Rho is the population correlation coefficient. If he asks you test for positive correlation, it will be this, greater than 0. If he asks you to test for negative correlation, it will be this one. If he'll ask you to test for correlation, he doesn't say positive or negative, it will be that one. So that's how you select it, guys. Since he says a positive, that's our null and alternative hypothesis going to be. So I'm just going to put it here. And here you don't put the claim here, it is the claim, but you just put correlation is significant in the alternative, and in the null you put correlation is not significant. I will scan my notes from chapter 9 and email them to you today from Monday's lesson. Correlation not significant. So if we fail to reject HO, the correlation is not significant. If we reject HO, that means we're supporting HA, correlation is significant. Okay, the test is called linear regression t-test, guys. That's the test that you can use. Okay, here's how you use the test. You already have the data in L1 and L2. You don't have to do anything here other than just run the test. So you go to stat, tests, scroll up, linear regression t-test. And look, guys, L1, L2, please pay attention here. There's only one step that you have to make. Choose the correct alternative hypothesis. Since the alternative hypothesis is greater than 0, you have to choose the greater than 0. And look, guys, it's already been selected for you right here. Enter and hit calculate. Okay, T is 12.11. 111. And the p-value, guys, what's the p-value? Let me show you the p-value. It's 9.625 E minus 6. I'm going to write it down. And don't ignore the E minus 6. If you ignore it, guys, then you will lose credit on the entire problem here. E minus 6 means you have to move the decimal point 6 digits to the left. So that means this is actually 0.000009625, which is almost 0. Less than alpha, reject HO. Definitely you're gonna reject HO when you see an E here, always. And then you say, since you reject HO, so this is bad, then you're saying correlation is significant. So you say there is enough evidence at the 0.05 level of significance to conclude that correlation, or that there is strong positive linear correlation, that correlation is significant. That would be good. Between weight of diamond and price. Big, strong relationship. You're confirming that. Predict the price of 1.1 carat diamond, guys. So you already have the equation. All you need to replace X by 1.1. So you do 6960.1 times 1.1 minus 91936.2. Okay, let me put it on the calculator. 6960.1 times 1.1 carat minus 1936.2. I got 5,719.91. And the last question. Find the coefficient of determination and interpret its meaning. R squared. You already have it on the screen, guys. It is on the screen. It was on the screen. Let me show it to you. I mean, you don't need to calculate it. There you go. R squared is 0.96. Okay. Here's how you interpret its meaning. Pay attention to this. You say 96%, you change it to a percent of the variation in the price of diamond can be explained by the variation in the weight. So always you put here the Y variable here, and here you put the X variable and the weight using the regression line. That's the language that you have to use when you interpret the value of R squared.
Mr. Bazzi,
Mhm.
Even though we're not really stating which one the claim is and which one it's not, but would the claim
Oh,
term
the claim is always in the alternative.
so it'll always be HA?
It will be always HA. Will be always to check if correlation is significant.
Okay.
Always you check if correlation is significant. He won't ask you to check that correlation is not significant. So the claim is always in HA. Yeah. So here's again R square, guys. Here's how you interpret it. You say 96% of the variation in the Y variable can be explained by the variation in the X variable. The Y variable, guys, here it's called oh, you see here it's a mistake. I should have put weight here. I'm sorry. And here price. I was wondering years and income. I used the same table from the previous exercise. So weight, please adjust this. That should be weight and that should be price. That's X and that's Y. So always for the interpretation of R square, guys, whatever percent you get, you say, let's say you get 85%. You say 85% of the variation in the Y variable can be explained by the variation in the X variable. And state what the Y variable is, state what the X variable is using the regression line. That should complete, just the question. One question you might encounter online, which is in addition to what you did here, guys, when you do the linear regression t-test, what was it? Yeah, right here, F. You see that S value, guys, he might ask you what's the standard error of the variation. That will be called S, and you get it from here. It's 490.9, but I didn't ask for it here. This is T, this is the equation. If you are to copy the equation from here, make sure to follow what it says, A plus BX. You attach B to X and then you leave A alone, and it will be exactly the same as this equation, guys, that we got right here. It will be exactly the same. So that concludes the review of chapter 9. I'm going to go ahead now and do a review for chapter 7